Here we're going to continue to talk about roots. And so if you haven't watched the part 1 video on roots, I would encourage you to do that. We're going to talk about some things that are going to get a little bit complicated. So it's important that you've watched the first video. And it's also important that you know your multiplication tables. You need to know offhand what, 2 times 5 is, and 3 times 7, 8 times 4. You need to know what those are offhand. Otherwise, this is going to be pretty complicated to be able to figure out just naturally. So please study your multiplication tables, and we're going to start talking about roots and about how to simplify roots. But what I have on the board here is I'd like you to write this down. These are some roots that you really need to have memorized. And again, if you know your multiplication tables, then this will be, pretty easy. But, the square root of 4 is 2. Because remember what a root is. Watch video part 1, roots part 1. What times itself is going to give you this number? So 2 times itself, 2, gives you 4. The square root of 9 is 3. 3 times 3 is 9. So the square root of 9 is 3. The square root of 16 is 4. Because what number times itself gives you 16? Well, 4 does. 4 times 4 is 16. The square root of 25 is 5. Square root of 36 is 6. So if you know your multiplication tables, 6 times 6 is 36, then when you see that, you know the answer right away. You really want to know and memorize these square roots from, square root of 4, square root of 100. The other two that I would say will be very helpful to have memorized is the cubed root of 8, which is 2, because 2 times 2 times 2 is 8, so that's what a cubed root means. And the cubed root of 27 is 3. 3 times 3 times 3 is 27. Just memorizing those two cubed roots could be helpful, as they may show up in questions, and then you'll know them automatically. So write these down and memorize these. You should know them inherently, because you should know when you see what's the square root of 64, you know that 8 times 8 is 64, so you know that the square root has to be 8. But if nothing else, memorize them. So I'm going to show you now how to simplify roots. If you get a question that says to simplify this, I'll show you how to do it. So let's say you get, and it says simplify the square root of 36. Now, this is an easy question because we already know what the square root of 36 is. It's 6. But I'm going to show you the process, because then we're going to apply that to more complicated problems where we don't know the answer when we look at it. So if we were going to simplify this, and this was the problem, what you want to do is break it down into those roots that I just had on the board, and see if you can find any of those by multiplying them together to get whatever is under here. The way this is going to make sense is just by doing it. So if we see 36, and let's say we don't know the root of 36, but we know that 4 times 9 equals 36. So instead of thinking of this as 36, we're going to think of it as 4 times 9. Again, this is why you need to know your multiplication tables. So 4 times 9 is 36, so instead of writing it as 36, we're going to take the square root of 4 times 9. Now this we can break up. So this is going to be equal, if this is a multiplication sign here, we can make this into the square root of 4 times the square root of 9. So we're just going to write it differently. It's still 4 times 9, the square root of the whole thing, the square root of 4 times the square root of 9. Now those you should definitely know offhand. The square root of 4 is 2. The square root of 9 is 3. So we have the square root of 4 is 2 times the square root of 9, which is 3. 2 times 3 equals 6. So the square root of 36 is 6. which we knew that before, but this is the process of how to do it. So you have your number here, you try to break it into a multiplication of numbers that you know the roots of, and because we're multiplying, we can write it like this. We can break these out and then solve the problem. So let's try one that's a little bit more complicated. 144. Now we may not know offhand what the square root of 144 is, but the other video that you want to watch is the video on divisibility, because we can start to think about, well, what can I write this so I can break it down? And so if you watch the divisibility video, you'll know that you can you can divide this by 4. And so how we're going to write this is 4 times 36. So we know this can be divided by 4, so we divide 4 into 144. So 144 equals 4 times 36. So now we can write this as square root of 4 times the square root of 36. And again, we know what the square root of 4 is, that's 2. We know what the square root of 36 is, it's 6. So the square root of 144 is 12, and you can check that by saying, what is 12 times 12? It's 144, and that's the definition of how we know what the roots are. So if it's multiplication, you can divide it out like I have here. So this was 4 times 36, because that equals 144, and we divided it into square root of 4 times square root of 36. Similarly, if you have division, so let's say we had this, and we'll go kind of in the opposite way, where we have square root of 21 over the square root of 3. Well, we don't know what the square root of 21 is. It's not, an even number, or is the square root of 3. But we can write it like this, 21 over 3, because this is division. Anytime you do multiplication or division, you can combine them. So 21 over 3. 21 over 3 is 7. So this just equals the square root of 7. Now we can't simplify that anymore, because the square root of 7 is not a whole number. So this would be the simplification of this, is you'd put it all under the radical sign, and then you have 7. But that would be the final answer, is the square root of 7, if you're doing a simplification problem. So I want you to make sure you understand, if you're doing multiplication, you can divide things out, or you can combine them. If we did this backwards, you can combine them. Same with division. You can combine them and then do the division. This is not true if you are doing addition. So if, let's say, we had the square root of 2 plus the square root of 5, we can't just add these. That is not equal to the square root of 7. You cannot add items that have different numbers under the radical sign. You can't add or subtract them. So here, like we had square root of 4 times the square root of 9, we could put those together and say the square root of 36. You cannot do that when you add. So please don't make that mistake. If you have the square root of 2 plus the square root of 5, that is not equal to the square root of 7. And you can plug that into your calculator. Find out what the square root of 2 is. Find out what the square root of 5 is. Add those two numbers together. You're not going to get the same number as if you put what the square root of 7 is. So I am going to show you, though, how you can add numbers that have the same number under the radical sign. So let's say you have this problem, 3 square root of 2 plus 9 square root of 2. When they're written beside each other, that essentially means multiplication, right? So 3 times the square root of 2 plus 9 times the square root of 2. And if you know the distributive property, this is a lot simpler. But if you don't, then you can just think of it this way. Since square root of 2, square root of 2, since these are the same number, we can only do that if it's the same number under the radical signs. Then all you do is add what's in front of them. So it would be 3 plus 9 times the square root of 2. This all goes back to the distributive property, but you can also just think about it. So we have 3 plus 9 is 12 square root of 2. So you can see all we did was add the numbers out front. 3 plus 9 is 12, and we left this alone. The square root of 2 we just left there. We didn't change it in any manner. Similarly with subtraction. If we have 7 square root of 3 minus 2 square root of 3, you just look at the number, because these are the same, they're both 3's, you just look at the numbers in front. 7 minus 2, which gives you 5 square root of 3. And that would be the simplified form. For this problem, your answer is 5 square root of 3. So those are actually pretty straightforward if you can remember that. You can only add them and subtract them if the number under the root sign is the same. But all you do is just, whatever the numbers are out here are, you just do that same operation. Now, I'm going to give you one more problem that is a little bit more complicated. So, if you have a problem, let's just say it's square root of 5 plus the square root of 125. So this is a fairly complicated problem, and it says simplify this problem. Well, we know that the square root of 5 is not a whole number because we have memorized the whole number ones, and we know in the multiplication tables that there's no number times itself that equals 5. So that is simplified as far as it can get. This, however, again, if you know the divisibility video, you can say, okay, well, what numbers do I know that go into that? And so I'm just going to now look at this. So we're just going to concentrate on the 125. We're going to try and simplify that piece of the puzzle. Well, we know you can divide it by 5, and if you do, you get 5 times 125. So now we can break this out. Square root of 5 times the square root of 25, because we instantly recognize that 25 is one of those that we have memorized. We know what the square root of 25 is, that it's 5. So we have the square root of 5 times 5, because the square root of 25 is 5. Now we don't normally write it like this. We would write it with the whole number out in front and then just put the radical sign beside it. So the square root of 5 times 5 can be written 5 square root of 5. So we know we can simplify the square root of 125 to this. So we're going to plug this back in for the square root of 125. So our problem, remember we had the square root of 5, so I'm just copying that down, plus, and we figured out that the square root of 125 can be written like this. So now we can simplify this, because remember, if we have an addition problem but the numbers under the root sign are the same, then we can actually add them. Now, there's actually a 1 out here that we don't ever write, because 1 times anything is just itself, so we don't have to write the 1. But there actually is a 1 out here. So 1 plus 5. So I'm just doing the same thing we just did before with the other problems, where I just took the number out here plus that number. I kept this the same, and we get 6 square root of 5. So 1 square root of 5 plus 5 square roots of 5 equals 6 square roots of 5. So the answer to simplify this problem is 6 square root of 5. I know that's fairly complicated, but if you watch the roots video and some of the other videos I've mentioned and really understand it, then you can understand better how to do this problem.